All right, we're in for another round of product and quotient rule. So sometimes we get some questions where we're asked to find a derivative and we're not given an equation for a function. We're not given an expression. We might have to do it graphically, or we're given some information on a table of values. It requires us to really wrap our heads around the true definition of these rules. So let's just jump right into the first example. F of x is defined as g of x times h of x, and we're asked to find f prime of 2. So kind of the first step here is to recognize that if you're asked to find a derivative at a point, you actually have to do the derivative first and then plug in 2. You can't plug in 2 yet. So essentially what I'm trying to say here is we have to find what f prime of x is equal to before we can start plugging in 2. So f prime of x is equal to g prime of x times h of x, right? Derivative of the first times the second, plus derivative of the second times the first. And it's just the good old-fashioned product rule. So now if I want to know what f prime 2 is, I can just replace all my x's with 2. So I have g prime of 2 times h of 2 plus h prime of 2 times g of 2, which is why all of this information is given to us up here. So change my color up and rewrite it up here. So we have f prime of 2 is equal to g prime of 2, which is negative 4, times h of 2, which is negative 1, plus h prime of 2, which was 5, times g of 2, which was 3. And now it's just simple arithmetic, right? Two negatives make a positive, and 5 times 3 is 15, so we get a final answer here of 19. F prime of 2 is equal to 19. Use the graphs of f and g to find the following if they exist. So differentiability could be a factor at play here. F prime, and sorry, a derivative will not exist at a corner, a cusp, a vertical tangent, a discontinuity. So we have some corners in these graphs, so we have to be mindful of that. Part A, h of x is equal to f of x times g of x. Find h prime of 1, so I'm just going to copy and paste what I have written up here, right? So just a rearrangement of my variables. H prime of x is f prime of x times g of x plus g prime of x times f of x. All right, so again, I replace my x's with 1s, so h prime of 1 is equal to f prime of 1. F prime of 1 is the slope of f at 1. Well, we've got a piecewise linear graph here, so f prime of 1 is equal to the slope of the line there, which is 2. So I'm going to go ahead and write that down already as a 2, times g of 1. G is the thick graph. G of 1 is 3, plus g prime of 1. G prime of 1 is now the slope of the thick graph there, and the slope of the thick graph is negative 1, times f of 1, and f of 1 is the y value, and which is also 3. So I'm just going to go ahead and jump into the math there. So that's 2 times 3, which is 6, plus negative 3. So we have 6 minus 3, which is 3. That's our final answer for that one. Next one, very similar, involves the quotient rule. So quotient rule here, so k prime of x is low d high minus high d low all over the low squared. So low is g of x, d high, f prime of x, minus high, f of x, d low, g prime of x, all over the low squared. So we have g of x squared. So if I go ahead and start plugging in 6, we are going to have, let's see, so we have 1, 2, 3, 4, 5, 6, right? So again, these critical points that we're analyzing the graph at doesn't occur at a corner. If I asked maybe k prime of 5 or h prime of 5, we'd have an issue because graph had a corner there. But I'm actually going to go ahead and just start plugging in. So g prime, g of 1, if I plug in 1, so we have k prime of 1, sorry, 6, I mean, when I do that, g of 1, thick graph, y value at 6, I keep saying 1, that 6 is right here at 2, times f prime at 6, the slope of the thinner graph here is negative a half, minus f of x, f of 6. The y value of the thinner graph there is 4 times b prime of the thicker graph there is negative 2 all over g of 6 squared. G of 6 is 2, squared is 4. So if I simplify all this, up the denominator we have 4. And then in the numerator we have 2 times negative half, which is negative 1, minus 4 times negative 2. So that's really plus 8. So negative 1 plus 8, which is 7/4. Find the points where the graph of f has a horizontal tangent. So again, some of you might be jumping to the conclusion that the quotient rule is the way to go for this. But it's not the most efficient way to do it, especially in this case because I can recognize that my denominator is a monomial. I would not be able to pull this off if my denominator had more than one term. But since it does, I can actually rewrite the function. So before I even take the derivative, I'm rewriting the function as 3x over x squared. This will show the work of this 3x over x squared, which I'll simplify in a second, and 2 over x squared. So I could really rewrite this as 3x to the negative 1 minus 2x to the negative 2. Now it's just simple power rule. So f prime of x is equal to, if I do the power rule, we get negative 3x to the negative 2 plus 4x to the negative 3. Find the points where the graph of f has a horizontal tangent. So we need to know where is this equal to 0. So we could go ahead and rewrite this with with fractions in it, or a method that I've used in the past is to factor out a GCF, which is kind of weird to look at because we have negative exponents. But if I pull out the smallest exponent, in this case, the smallest exponent is the one that's the most negative here, which is negative 3. So I could actually factor out an x to the negative 3 here. So kind of undoing the distributive property here. So that would mean that this is actually negative 3x plus 4, right? And if you want to double check, if I distribute in to the parentheses, I would land back where I started. So we're trying to find whether this is equal to 0. So I set both things equal to 0. If x to the negative 3 equals 0, and negative 3x plus 4 equals 0. And for this one, we get x equals 4/3. For this one, remember that this really is like this, right? We get 1 over x cubed is equal to 0. So that never equals 0. It's always going to be, it would have an asymptote, right? This graph would have an asymptote. So there's not a possibility here. So we only get x equals 4/3. So if we wanted to, we could actually calculate that the answer would be 4/3 comma f of 4/3. And that would be my coordinates, and I could plug in 4/3 in there. But to save time for now, I'm just actually going to just leave it as that, right? Or again, plugging in 4/3 into this guy. But like I said, we're going to leave it like that. Okay.